Welcome back. We're going to continue our study of conic sections by looking at parabolas. These are things we've already seen in the context of studying second-degree polynomials. So parabolas are familiar to us in the context of degree 2 polynomials. Right, so these are the ones of the form y equals ax squared plus bx plus c. And we've seen that they look things like this, these sort of bell-shaped curves. Now we'll think about parabolas in a more geometric context. We'll think of them similarly to ellipses and circles as sets of points with a special geometric property. So for us, parabolas will be sets of points whose distance to a fixed point and a fixed line are equal. So I imagine geometrically that I have some fixed line and some fixed point. And I'm looking for a curve whose distance to the line at every point is equal to the distance to this special point. So the idea would be to have this distance be equal to that distance for every point on the parabola. Now we give a special name to the line and the point. The special line is called the directrix, and the special point is called the focus. How do these ideas relate in the formula for a parabola? Well, our formula will be something like y squared equals 4p times x, or x squared equals 4p times y, where this number p determines the directrix and focus. So let's look at an example to see how this works. If we have y squared equals 8x, we'll try to plot this. So 0, 0 is going to be on this plot for sure. So 0, 0 is on the plot. And let's see, when y is equal to 1, let's say when x is equal to 1, y will be equal to like the square root of 8, so something like 2.7. When x is equal to 2, y will be equal to the square root of 16, so something like 4. So our picture is maybe something like the following. Something like this. And then if I write y squared equals 8x in the form 4px, then p is equal to 2. So that's this special number here that determines the focus and the directrix. So the focus is here at the point 2, 0. And then the directrix is this line here at x equals negative 2. So in the case that I have something of the form y squared equals 4p times x, the focus is at p, 0, and the directrix is x equals negative p. And then similarly, when I have something like 4py equals x squared, the focus is at 0, p, and the directrix is at y equals negative p. So the only thing that really changes is my orientation towards the x-axis or towards the y-axis. So let's look at an example now where I have orientation along the y-axis. So let's plot the parabola with directrix y equals negative 2 and focus (0, 2). So let's start by plotting those points. So I have 0, 2 here, and y equals negative 2 here. Okay, so we're going to have a parabola that opens upward. And now let's just look at the situation. If I have my directrix of the form y equals negative p, and the focus is of the form 0, p, which this is, then I'm looking at something of the form x squared equals 4p times y. So my formula will be x squared equals 4p times y. And in this case, p is equal to 2. So I'm looking at x squared equals 8y. Now, if you wanted to write this in y equals form, you could write it as 1/8 x squared. So let's see, when x is equal to 2, y will be equal to 1/2. When x is equal to 4, y will be equal to 2. So the picture is something like this. So we just have to think about parabolas a little bit differently when we study them in this context.